Thanks to everyone for taking the time today to learn a little bit about ARES. So within our organization, we have dozens of observational data sources, many of which have been converted to the OMOP Common Data Model. And we've leveraged existing tools from the OHDSI community to provide data characterization and quality assessment. So specifically, we use Achilles and the data quality dashboard actively within our group. And the tools have served us very well over the years. Achilles has been the primary source of data characterization for our group since 2014. I actually went and looked how long ago it was that it was originally built. And having personally worked on both of these tools, I fully understood the value that they provide to the group, as well as the opportunities we had to take a next step with them. So existing tools had several limitations. Specifically, while they provide adequate characterization of individual data sources, they lack any kind of overall network assessment across data sources. Additionally, the tools did not provide any access to historical data. So once new releases of data sources were published, the prior version of the characterizations that had been in Achilles were no longer available. And there was no integration of any kind between the characterization that we saw in Achilles and the data quality results that we saw in the data quality dashboard. So for example, if you're looking in Achilles at a comorbidity report, trying to do a feasibility analysis, see if there's enough people with different condition concept codes appearing, you would have no visibility to data quality issues that might exist unless you went over to the data quality dashboard to look at that data independently. And frankly, almost no one was ever taking that next step. So to address these limitations, we worked toward a set of analyses that could better integrate characterization and data quality work, as well as provide ongoing access to data source changes over time. And these improvements and new capabilities were built into a tool that we call ARES. So ARES stands for a research exploration system, and it builds upon the work that we've done with Achilles and the data quality dashboard. It provides solutions to those limitations I just described. And at this point, we'll jump over to a live demo. The site I have up here is ARES, and we'll just walk through some of the capabilities so that people can get familiar with how they might be able to use it. So ARES provides reporting and analysis at 3 distinct levels. And this is a departure from some of what we've had in the past in Achilles, so I did want to spend a little bit of time describing it. So the 3 levels are the data network, a data source, and a data source release. And you could choose which level of detail you're looking at here in this top left area. So the data network is as it sounds. It's the listing of all the data sources that are available within this particular network. Within J&J, we have a network of OMOP Common Data Models available that we use for all of our research. And whenever you're looking at this data network level, you're going to be looking at analyses that are going across the broad network. The data source level, what that means is we have data from, say, IBM called the Commercial Claims and Encounters Database, or CCAE. That is a data source, much like Optum DoD is a data source. A data source release means the data that was delivered to our organization on a particular date. So in July, we received new data from a vendor, and that is the data source release. So all 3 levels are available from within ARES, and each of those levels has its own list of available analyses. So here we're looking at the data network overview, where you can find a list of all the data sources currently available that have been converted to the common data model. For each database on this overview, you can see the total number of people, the total number of data quality issues that were found, the date of the latest release, the number of releases that we have available, and the version of the vocabulary that was used to do the standardization. And you could scroll down through this list to review all of the different data sources that are available in our network. From this overview, you could click on any of these buttons to dive into details on that individual data source. But for now, we're going to stay at this network level to look at some of the other analyses that are available. Okay, so at this data network level, there are a number of different analyses available. We're going to switch over to this quality assessment view. So Disco has been using ARES for a while now, and it's been helping us to understand our overall data quality issues at the network level. And this quality assessment shows us all the data quality issues across all of our data sources. The issues are summarized by the con framework categories in the first visualization. And in the visualization below, you can see that most of those issues occur with regard to the measurement table. So you can see that this is across the entire network, right? So each of the network databases are one segment of this colored chart. And so we use this within Disco to say, if we're thinking about data quality, where should we have our focus as we try and address things that we're identifying as data quality issues? So we actually had a few day event we called Measurement-a-Palooza, where we went and dug into all of the measurement plausibility data checks. We've made substantial changes to that, and in our next round of CDM refreshes, we hope that those improvements will show up. So people are often curious about the data sources and the populations they represent. And this population overview visualization shows us the distribution of age at first observation across all of the network databases, with each data source represented as its own series on the plot. So here we see most of our databases are actually quite similar, except for the IBM MDCR database. Not surprisingly, being our Medicare database, it has a large proportion of people with their age at first observation as 65. So you can see the spike in the chart here. Below, we have cumulative observation. And again, we could see that a lot of the data sources have somewhere between 2 and 10 years worth of cumulative observation, with an outlier being CPRD, where we see a much longer tail. Now, I don't want to suggest that you would use this information to inform on a particular study necessarily, but it does give you a sense of the populations represented across the entire network. And if by some odd chance you needed 25 years worth of cumulative observation, you would know that you have very limited options. This last report at the network level is a visualization called the data strand report. And it allows us to see the composition of each of the databases by the common data model domain, or essentially table, across the entire network. So if I look at this Health Verity vaccine database, I can see that 42% of the records are in the condition occurrence table. However, if I go and look at something like the Optum EHR COVID database, you can see that only 12% of the records are the condition occurrence table. So to interpret the plot, it's essentially a stylized categorical bar plot. So you're looking at each row here as a data source, and then each color represented is the table from which the records are appearing in the data set. So you could rather quickly, at a 50,000-foot view of the network, see which data sources are made of what type of information, and understand a little bit more about the database from this high level. So I'm going to take this down a level at this point and go from the network to the data source. And at this point, I think we'll just we'll pick Optum Extended DoD, and we'll look at data quality history. So when I talk about a data source, it can sometimes be confusing. So I want to make sure it's clear. generally speaking, when you go into Achilles or Atlas today, there's one version of a database given as a particular name. So, like I mentioned earlier, IBM Commercial Claims and Encounters, or CCAE, or in this case, Optum Extended DoD. But as I think we're all aware, these databases get updated sometimes quarterly, sometimes semi-annually. It's just been the case historically that we don't have a view of the history of these data sources. And so within ARES, this report level of a data source allows us to see what's happening within that data source over time as different updates occur. So when we look at this historical data quality analysis, what we're seeing is the number of checks that have failed on the y-axis over time on the x-axis. So this isn't the time that's represented in the database. This isn't the time where an individual had a diagnosis. This is the time where we received and processed the data. That's what these timestamps represent. So in the table below, you could see when the CDM was released, when we ran the data quality dashboard, the number of checks that passed, failed, and the total number of checks that were performed. So here we could see that we'd been having good progress, dropping the number of data quality issues, and then we've seen a little spike in Optum Extended DoD. Below this top level plot, we have stratified the data quality issues by category and domain, similar to what we were doing at that network level. And what you see is that plausibility seems to have driven the complete increase, as well as data in the measurement. So looking into this, we know that we've recently made some changes to the ETL process where the measurements that were coming from the native database into the standard database that had zeros had been getting dropped because they seemed to be irrelevant measurements, but we want to make sure that we're capturing them. So with that change, this is actually a good sign for us. We were like, oh, okay, the change we made did what we thought it should do. It introduced those measurement records back into the data set. Now we'll just have to hope Measurement Palooza saves the day and gets us back to a place where we're able to assess the quality of the measurements, and then hopefully as we're planning, get to a point where we're cleansing these data quality issues from the data sets before they're released. The other analysis that's available at the data source level is what's called domain continuity. And so from one release to the next, there are often changes to the data we receive from a vendor. And we do everything that we can to provide awareness to the changes. So Clair is typically sending out an email, and if there are highlights, we try and put those into that email that describe what's going on. And so often when a study goes from a release and a new data source is released and the study reruns some analyses, cohort sizes changes. And it's helpful to know what underlying factors may have caused the difference. So sometimes that may be caused by changes in vocabulary, but it could also be caused by changes to the underlying data itself. And that's what this domain continuity report allows us to see. We're looking at the number of records. Again, this is not a drug error that occurred on a particular date for a person. If I scroll down, you can see the time axis here at the bottom. This is the number of records that existed in the data set on the date we received it and processed it. So we could see that, for example, drug error records were at 1.6 billion at one point, and now recently has dropped to 1.4. The number of persons has also dropped. So is the number of procedures. And so in particular, this case raised some eyebrows on our side. And as we looked into this, we learned that actually our contract had changed with the vendor, in this case, Optum. So we had been receiving data, I think it went back to 2000, but recently the contract stipulated that our data would be capped from 2007 and forward. So going forward, this data set will have less data than it used to have, And the reason for that is a contract change that will potentially affect people's work and studies that you're doing if you, for example, had been using data or had individuals with data that were extended prior to 2007. So this type of analysis allows us to track changes like this on an ongoing basis. And this is a type of report that the DISCO team reviews each time one of our data sets is updated. Everything that I've been showing up until this point represented new network and data source level analyses, but I wanted to demonstrate that we still have the types of descriptive statistics that we've always had for each individual data source release. Just now you actually have the option to look at which version of the results you want to view. So to get down to what was legacy Achilles types reports or the data quality dashboard website that we had, you choose data source release. And we'll look at, I guess we'll stay with the Optum extended, that's fine. We'll choose the release. So here you can see the 4 releases that are currently available from within ARES to go and investigate the results for. Then here we'll look at the data quality report. So the overall format of the data quality report hasn't changed, and you could still review complete results, filter for data quality failures. Each report here, along with this dropdown where you could choose one, represents one of those data points we were just looking at on the data source data quality history report. So each of those time points, this is the full report. So all of the information within it that that occurred when we ran the analysis for this release of the database. Again, for those who are familiar with Achilles, I'll move through this a little bit quickly, but all the same types of Achilles reports are available here. So we have a person report where you see the population by age and sex stratified, population by race, population by year of birth, and so on. There is a data density report, which shows the number of records stratified by the table or domain within the common data model over time. So this is one of those places where if you were interested, you could go and drill into what's happening in a particular time range. For example, what you'll see throughout ARES in a couple places is this double chart view where you see the same chart on top and a smaller version on bottom. The bottom version allows you to click and zoom. So if you want to drill into a particular time frame, you can see that for some reason there was a drop off in the number of records that occurred somewhere in this case, we're looking at 2020 in March and April. So I think we could all assume what's happening here. Within observation period, we have a chart that shows us cumulative observation and observation over time. Again, as you mouse over, you could see here that roughly 27% of people have at least 3 years of observation in this particular data set. So you could use the observation period report for those types of assessments. When I go over to conditions, again, very similar to what we had in Achilles, it's a list of all the concept IDs. So these are not phenotypes, these are not concept sets. This is an individual concept identifier that is found in the data set, the percentage of people that have at least one record, and the number of, or the average number of records per person. This button here allows you to choose other columns. And so, for example, we had a request that for people to be able to see the raw number of people. So that is also available here. One thing that I'll show is you could click on any individual one of these concepts and then see a drill down report. So it'll show you the concept ID, the number of people, the percent of people, the number of average number of records per person. And we've also started implementing some temporal analyses within ARES. So doing temporal characterization of data sets. And in this case, we see a notification that this happens to have a non-stationary time series. So if I scroll down, You could see that the record count proportion by month seems generally stable, and then there's this jump. Without getting into why we might necessarily see the jump, this temporal characterization is giving us the ability to identify data that potentially has issues. In this case, this isn't necessarily an issue, but this temporal characterization is throughout ARES and is trying to assess the temporal stability of our data sets in various different ways. The other thing I'll go and do is show you, let's pull up the measurement report, I think is a good example. So the measurement report, same scenario for each concept ID. You'll have the number and percent of people, the number of records per person. One thing I wanted to highlight here that speaks to the idea of the integration of the characterization and the data quality is here you see in the top right that there's an icon with an indicator that in the measurement domain, there were 248 data quality issues identified. And so if you click over, it'll take you to the data quality results. So you could see exactly where there were issues. And again, this is one of those situations where if you had a specific measurement that your study was going to be focused on, you could evaluate whether or not those data quality issues that were identified would be meaningful. Jumping back to the slides as we're wrapping up, I wanted to make sure that for those who are interested, there's a high-level overview of the technical implementation details for ARES. As I mentioned earlier, ARES builds off Achilles and the data quality dashboard, and I mean that both figuratively and literally. The existing Achilles and data quality dashboard R packages are used as part of the data analysis process. When those are completed, a separate package called the ARES indexer is used, also implemented as an R package. It completes the network and data source analyses that are then available through the ARES web application, which is a very simple combination of just HTML and JavaScript. There's no web service layers involved.